Good morning, good afternoon, and good evening, everyone. A big welcome to all of you to this Maritime Ammonia Insights webinar. My name is Sofia Fürstenberg Stott. I'm one of the two maritime directors to the AEA. And I have the great pleasure today of moderating this much anticipated session on exploring the outcomes of this report, Ammonia at Sea, exploring potential impact of ammonia on marine ecosystems. Together with me today, I have 3+1 panelists. I have from the Environmental Defence Fund, the Director of Global Shipping, Cabbia Hubatova. I have from the Lloyd's Register Maritime Decarbonisation Hub, their decarbonization risk specialist, Mr. Samie Parkar. And from Ricardo, I have their Associate Director, Steve Coates, who will later in the Q&A be joined by his colleague from Ricardo. She's a senior water quality technical specialist, and her name is Lauren Dawson, and will help us especially on some of the questions related to toxicity. So I would first like to let you know that this session is being recorded, and you will be able to find this session later on the AEA's YouTube channel. For those of you who may not know too much about the Ammonia Energy Association, this is a global non-profit industry association that promotes the responsible use of ammonia in a sustainable energy economy. The scope of that work includes both the decarbonization of ammonia in existing applications and adoption in new ones, which is where maritime comes in. And as maritime directors for this organization, we are trying to bridge the maritime industry and their needs with this emerging energy sector and try to help both parties understand how to progress together. So about the webinar today. So the ambition and commitment to decarbonize global shipping has forced the industry to look at other sources of energy. And as we are all very well aware, ammonia has been considered as one of those prominent alternative fuels to decarbonize shipping. But we're also very well aware that ammonia is toxic. How toxic is ammonia, and under what circumstances? We also know that ammonia is a fertilizer. Too much fertilizer can cause eutrophication, a complicated word that essentially leads to a lack of oxygen in our oceans. So what happens when we have a major release of ammonia into the sea that comes from either a collision or grounding of the ship or something that happens during the bunkering phase? What happens to different marine ecosystems? What happens to mammals, to birds, to fish, to other animals at sea? And what's the difference between a large and acute spill and that of a smaller one that maybe happens over a longer time? And how does all of this compare to what we are already doing when we use conventional fuel oil? So I hope I've given that a fair summary of what this report has actually tried to look into. These challenges is what we are gonna hear more about, and how all these three actors have tried to address these in this joint study. So without further ado, I would like to welcome Cabbia Hubatova to the stage to start the presentation from the Environmental Defence Fund.
Thank you so much, Sofia, and good morning, good afternoon, everybody. Thank you for joining us. So I'll tell you a bit more about why we wrote this study and a bit more information about the context of ammonia within the shipping industry. Next slide, please. Thank you. So international shipping produces over 1 billion tons of CO2 every year, which is about 3% of global greenhouse gas emissions. If it was a country, it would be a major polluter. And there has been an increasing pressure on the industry to do something about its carbon footprint, which is why 5 years ago, the International Maritime Organization, which is the United Nations governing body for international shipping, agreed to reduce the sector's emissions by at least 50% by 2050. Now, we know that that ambition is not strong enough, and for the sector to do its fair share in the global push towards decarbonization, it should really be in line with the 1.5 trajectory as described in the Paris Agreement. So that would mean effectively peaking emissions now and reducing during this decade with ambitious interim targets for 2030 and 2040, and phasing out emissions completely in the 2040s. We know that there is that some reductions can be achieved through improving energy efficiency, operational measures, or using alternative ways of propulsion. But to phase out emissions completely, the sector will ultimately have to move away from fossil fuels and look at fuels that do not produce greenhouse gas emissions at any point of their life cycle. So that means not just emissions produced on board during combustion, but also emissions that occur upstream, so during production and supply chain of those fuels. Next slide, please. So we have several fuels on the table as alternatives, and ammonia is one of them. It is a popular option for multiple reasons. So I've listed some of them here, the main ones, at least from my perspective. So we know that ammonia is from some perspectives better, or has better properties than hydrogen. Speaking of, for example, energy density or ease of storage. It can also be produced with renewable energy, which ticks the box of no upstream emissions. It's also easier than some other fuels in terms of production if we really are looking at no upstream emissions, because it doesn't contain carbon, so that makes it more favorable than, for example, e-methanol. And also ammonia has been carried by ships for a long time as cargo, so the sector has certain experience with carrying ammonia already. And so for those reasons, ammonia is seen as one of the forerunners for shipping, and plays a really important role in many decarbonization models for the sector. And it is expected to take up a significant share in the future fuel mix. Next slide, please. But as Sofia mentioned earlier, there are many challenges related to ammonia as well, and there are many questions that need to be answered. I think it's important to say that we've been using oil to power shipping for around a century now, and we learned more or less to use it safely, or well, at least we improved our way of using it, let's put it that way. But we can't really afford to have the same learning curve with ammonia or any of those new fuels. We have to get it right from the very beginning. And because shipping works on long horizons or long planning horizons, the ships that we produce now will still be around in 2050. And we definitely don't want to go for a solution that will eventually not work out, because we would end up with stranded assets. And I think nobody wants that. So the questions are, well, these are just a few. I think I'm sure that the more work is done to look into these, the more questions we will have. A big part of the gaps in knowledge are related to toxicity. So we need to understand better the impacts on ecosystems, not just on marine ecosystems, but also on terrestrial ecosystems. But we also need to understand impacts on health of crew of the ship, but also on communities, whether it's communities in ports, whether it's communities around shoreline or close to the supply chain locations. We also need to understand better nitrogen deposition and chronic leakage. And we also need to understand the impact of ammonia on climate and air quality, mostly from combustion byproducts. And understanding all of this, and probably many more questions which we are maybe not even aware of yet, is really important to make sure that we can use ammonia for shipping and we can do it in a safe way. That's it from me. Thank you.
Marie, thank you so much. Yes, indeed, we have many different challenges that we need to solve. Why I think this pioneering report is so important is because you have actually tried to model what can potentially happen. You have used existing data that is out there to put that into models and try to get the best possible answer of what happens next. And so I think that would be my bridge and lean in to Samie, who is going to introduce to you how Lloyd's Maritime Decarbonisation Hub have worked on this project with developing these models and what these scenarios are telling us. Samie.
Great, thank you very much, Sofia, and also Marie for a great introduction to the project. So yeah, if you can go to the first slide. Yeah, so I'm just going to go over how exactly we modelled these spills of ammonia to water. So just to give a bit of background for the basis of these spills, before this project started, actually, Lloyd Register, along with the Maersk McKinney Centre for Zero Carbon Shipping and various other partners, started a QRA. So this is what's known as a quantitative risk assessment, with the aim here to understand the risk on board vessels, which would be using ammonia as its marine fuel. So the main aim of the study was to understand the consequences of unintended releases of ammonia on board, and ultimately what the risk would be to crew members on board the ship in terms of risk of fatality. So as part of this QRA, 3 reference designs were assessed, each with ammonia stored at different conditions. So we looked into a container ship, and here the ammonia was stored in its fully refrigerated state. We looked at a bulk carrier, where the ammonia was stored under pressurized conditions. And we looked at a tanker, where the ammonia was stored in a semi-refrigerated state. So like I mentioned, the focus for that work was what if there was a leak on the ship side of the bunker flange. So the question that arose from that was, well, what if there is a leak into the sea? So essentially, we identified two different scenarios which needed to be modelled. Firstly, what if there was a leak at the bunker station on the shore or seaside? And also, what if there was a leak of ammonia into the sea from the failure of a tank, maybe due to a collision or grounding of a vessel? So if you can move to the next slide, please. So the next question is, well, how does ammonia behave when it spills onto water? So before we undertook our modelling, we carried out a literature review to find out what work has been done and what knowledge already exists on this subject. So surprisingly, we found that from our literature review that there's actually quite limited data on the analysis of ammonia spills. And back in the 1970s, the US Coast Guard actually recognized this need to actually understand the implications of large accidental spills of ammonia. And they recognized this need due to, at the time, the increased transport of anhydrous liquefied ammonia. So they actually carried out various experiments with different test spills of different scales. So they looked at laboratory spills, spills in the laboratory, spills in the swimming pool, and spills in the lake. So what they found from these studies is that when liquefied ammonia spills directly onto water, a spreading pool of liquid boiling ammonia forms on the surface, and approximately 70% of the ammonia dissolves into the water. And of the proportion of ammonia that dissolves into the water, we end up with the equilibrium I've shown in the equation on this slide. So you can see on the left side of this equilibrium, we have what we call unionized ammonia, so NH3. And on the right-hand side of this equation, we have our ammonium ion NH4+. And this equilibrium can be influenced by the pH, temperature, and salinity of the water. So what they found was that a high pH and high temperature shifts the equilibrium to the left, and a high salinity shifts the equilibrium to the right. And why this is important to understand is that it's the unionized ammonia, NH3, which is toxic to both marine and human life. So if you can move to the next slide, please. So now I'm going to talk about the modeling process and how we actually did this. So the modeling was carried out using industry recognized process hazard software known as FAST. And this software actually utilizes what's called the Raj and Reed model, which is based on the previous studies that I mentioned. And that model basically sets the parameters for the interaction between ammonia and water. So we modeled scenarios for each vessel type, the container ship, the bulk carrier, and the tanker, under various weather conditions and at day and night. And there are essentially two sets of results that we had from these scenarios. The first set looks into the pool. So how big is that pool? How much of that pool dissolves, how much vaporizes, how far does it spread? And secondly, our second set of results is the gas dispersion results. So from that vapor cloud that formed from the pool, what are the characteristics of that cloud? And I've just shown as an example what the typical outputs look like for this. So on the left, we just got a case where we show how the radius of the pool changes with time. And on the right, what we were able to obtain is the cloud data at various heights of interest at specified concentrations. And we repeated this exercise for marine gas oil, which allowed us to have a comparative assessment between the proposed fuel ammonia and an existing fuel that's already being used. So if you can move to the next slide, please. So in terms of the conclusions we found, or the results from our modeling, we found that the weather conditions have a significant impact on the spread of both the cloud formed from the spill and the actual pool itself. The worst case spill scenario was found to be from a hole in the storage tank due to a collision or grounding event. However, it should be stressed that this is a very low probability event. So the most likely worst case scenario is essentially a spill of ammonia from a full bore rupture of the bunkering line under low wind and stable conditions. However, it should be noted that all models do have their limitations. So I'll just mention a couple of these now. So for this particular study, the model utilizes weather conditions typical for the port of Rotterdam. And this was chosen as it's one of the busiest shipping ports. However, this obviously is not representative of weather conditions in different parts of the globe. There might be areas where hurricanes are more likely, or obviously in the polar regions where it's colder. So this reduces the applicability of the results in regions with quite different conditions. Another quite important factor is our model couldn't It didn't consider variation in pH and salinity of water, and that was just a limitation in the actual software. So as I mentioned before, these are two key factors which can affect the equilibrium, which can result in a higher proportion of unionized ammonia. So it's key that any future modeling can try and consider the effects of pH, salinity, and temperature. And finally, as I mentioned before, a lot of our models was based on data from experiments carried out in the late 70s and 80s. So I think further experimental data on spills would be required. Firstly, to be carried out on a larger scale, and secondly, just to validate those results and give us more confidence in our models. I think that's the end of my slides. Thank you.
Samie, thank you so much for that. Indeed, so you created these models and you accepted the kind of limitations that you had to deal with and the simplifications you had to accept because of you couldn't use pH, salinity, and temperature in the model, etc., etc. But you created those models and you provided scenarios, and then Ricardo came in, and they have been, as far as I understand, been searching all over to find toxicity data to evaluate how these different scenarios will impact marine life. And so for those of you who don't think about toxicity a lot and what that means to living organisms, you have ways of, coming up with concentrations that may be lethal to an organism. That maybe you can consider a worst case. But you have other concentrations which maybe start hampering the development of these organisms. You get chronic challenges and they may be slower down, or they may not find their food, etc., etc. There is a whole plethora of things that can happen when you are in an environment that is toxic to you. I'm not the toxicity expert, so I will not spend any more time trying to explain this. But on that note, I would like to invite Steve Coates from Ricardo to share the results on the toxicity performance of ammonia and comparing that to fuel oil.
Great, thanks for the introduction, Sofia. Yep, I'm Steve Coates. I'm Associate Director Ecology at Ricardo Energy and Environment. I head up the aquatic part of the business, and as I say, this is very much a team effort from Ricardo. I know Lauren's on the call, and hopefully Lindsay's in the background somewhere as well. So we're part of the energy ecology team, but also wider, we have an ecology team which help us support a lot of our work. I suppose a bit about myself. Prior to consultancy, I was actually at the UK Environment Agency for 20 years, initially involved with the recovery of the Thames estuary, and then latter years I was involved with developing European Water Framework Directive classification tools, and also developing some of the transitional and coastal environmental standards for the UK. So very much in the aquatic sort of zone, so to speak, as part of my career. And yeah, I'll just run you through these slides. And so if we have the next slide, please. So with our scope, we looked at a whole range of habitats. So not just marine, I may add. We looked at rivers and estuaries and the ecological receptors and groups of species within those habitats and environs. So you can see there was quite a depth and breadth of studies. Again, what I would add is, we're looking at species groups, and so we're having, in some cases, we're having to use individual species as surrogate for a family of organisms, be they fish, birds, mammals, etc. Could I have the next slide, please? And just in relation to those species groups and habitats, I suppose the key impacts of ammonia, and Samie touched on it in his presentation, it's very much the unionized form of ammonia that's of greatest concern, because obviously that's the one that's most toxic, and in particular in relation to fish. A lot of my background when I joined what was the National Rivers Authority, if we had sewage treatment work failures, and basically we had unionized ammonia going into rivers, then we'd get quite significant fish mortalities downstream. So from our kind of studies, there's a lot of information there in relation to fish as a species group, and again you can see, and particularly because they're breathing the water through their gills and the epithelial surfaces on their gills. That's one of the reasons why they're one of the key sensitive species. In relation to the habitat, so I'd probably say the rivers, estuaries, wetlands, and coastal waters and reefs, and mangroves are the most sensitive. I mean, that shouldn't be something that's not obvious to many. Again, that they're sensitive coastal areas where a lot of these sensitive species are found. So from our review, again, the main thing is in relation to, I suppose, as a species is increases in algal growth, because in essence, ammonia at certain levels will stimulate that primary productivity within the aquatic environment. However, once it gets to a level within the water itself, i.e., concentration, then there are secondary implications in relation to how it impacts those organisms and environs. If I could have the next slide, please. In relation to the toxicity elements of it as well, we obviously tried to quantify this in relation to areas that are of high impact and low impact, and also in relation to our comparison with marine gas oil as well. So all of this is summarised within the report. So next slide, please. Yeah, I mean, in relation to limitations, there's limitation in everything. Obviously, there is information out there within the scientific community, but there is a limited number of sources, and one of the key things is that most of the ammonia toxicity work seems to be undertaken in relation to runoff or from natural sources. There are definitely knowledge gaps when it comes to looking at ammonia spills in depth, and also on the impacts of ammonia spills on multiple habitats and receptors. One thing I would add, that of those receptors and habitats, it's very much a broad brush approach in that we've lumped things together. Obviously, within habitats, there are a lot more micro habitats within one particular habitat per se, be it a river or a coastal zone. And also, in relation to that, there's also the species themselves. You can break things down into species groups. The modelling aspects, again, Samie touched on that. The multi-parameter assessments, again, the environmental factors such as pH have not been considered, and salinity. We haven't considered nitrogen loading in relation to that, and the environmental fate of products with ammonia release. The ecotox studies themselves, again, we're using historic evidence bases because, again, there's very much now ethical concerns in the experiments on vertebrate animals, and in particular, things like fish as well. So, again, we're having to use research from 20, 30 years ago, and obviously that also impacts on our conclusions themselves. In relation to recommendations, well, obviously there's the feasibility and effective regulatory measures should be investigated further. Effective sort of health and safety measures should also be considered in relation to the safe implementation of ammonia, and also the evaluation of chronic ammonia spills needs to be assessed from our perspective, and particularly in relation to exacerbating issues in relation to algal blooms, etc. That should be me. Next slide. Thank you.
Steve, thank you so much. And thank you for all your presentations. Now we have come to the very exciting part of this webinar, where we will start asking you all kinds of questions. And I have the honor of being first in doing so. But to all of you listeners out there, put your questions into the Q&A. and I will pick and choose from those as we go through. There are several of you who have also sent us questions prior, and they have also been looked at from the panelists, and so I will pick from those as well. And I will invite Lauren Dawson to join us here for this, as well, as there might be questions that you are better placed to answer. But so I started with saying that this is a pioneering report, and for the very first time we have as good attempt as possible to try and understand what we need to do now in order to develop ammonia as a safe fuel, not only for the health of our seafarers, but also for the surrounding environment. And I want to start with you, Marie, and this is a rather big, hairy question maybe, but what is the key message that you want to bring to policymakers based on this report, and why is that the case?
Well, it's complicated. I think that the main message, if it was just one, would be that we really need to do much more work to understand better the implications and potential challenges, so that we can then design regulations and policies that will enable safe use of ammonia for shipping.
Yeah, thank you. Samie, I have a question for you here. You are going through the limitations of these models. What needs now to be done to improve these models, and can improved models help advising design of future ships?
Thanks, Sofia. Yeah, in terms of improving the validity of the models, I think what we need is large-scale experimental tests. So actually, interestingly enough, the HSE, so the Health and Safety Executive in the UK, do actually have plans to actually carry out larger scale spill tests for ammonia, and as part of these tests, they'll look into different terrains, the effect of obstacles, the effect of temperature, and hopefully they could also go into the effects of pH, salinity, and the water conditions. So I think we need more and more of those experiments. We can't just rely on one organization, and the more experiments and the more data we have, the more valid our models can be.
Thank you, Samie. To Lauren and Steve here, we recognize that we have very old toxicity data that we need to use for this. The toxicity data that exists has not been provided we are in a totally new situation. The toxicity data is for like runoff from agriculture and those kinds of situations. And now we have a possible situation where we have a big release of ammonia into the sea, and we are using toxicity data that is not really related to that. And still you have done this assessment with the best available data possible. What are you most concerned about right now with regards to the gaps in this evaluation?
I would say, I suppose, like any evidence-based approach, we've made a series of assumptions, and whether or not those assumptions need to be challenged or validated further, that's one thing we probably do need to consider. In relation to the evidence base that we've collected in relation to ecotoxicity, then potentially there could be ways to move that forward in relation to whether or not we can establish some form of machine learning modeling ecotoxicology approach. I don't know. It's something we probably need to consider and probably discuss further with the academic community and those that are kind of pioneering this sort of machine learning perspective, and whether or not we can draw upon that to generate thresholds which would be considered, you know, toxic within the aquatic environment associated with ammonia.
Thank you, Steve. Lauren, maybe you can help me answer to this. You have looked at the different what is it, the correct term? The different water regions. You looked at the mangroves, the rivers, the lakes, the deep sea, etc., and certain regions are more sensitive to ammonia than others based on your assessment. Would you be able to say at this point that there are certain areas where we should try to avoid introducing ammonia as a marine fuel altogether, that the risk is simply too large?
At this stage, that would be difficult to say. When we looked at sort of all the different habitats, so the mangroves, the coral reefs, the estuaries, we based their sensitivity to an ammonia spill based on their physical parameters, so their pH, their temperature, and salinity, as Samie was saying, was sort of the model is based off of, because that affects how that ammonia on the water, that affects its equilibrium and how much is either the ammonium ion or the unionized ammonia. So you could make some assumptions based on that sort of general physical parameter knowledge, but those parameters change through the day. They have sort of diurnal fluctuations. They change with seasons as those parameters change. So temperature, for example, you'll get different temperatures in those habitats with different seasons. So you could sort of say, well, temperatures are typically higher in the summer in sort of most of those sensitive sort of mangroves, for example, and say probably best to avoid during those times, but we don't have the data to be able to say, you know, completely cordon off this type of habitat, because we don't have any real world scenarios yet where a spill has happened to be able to sort of look at those impacts and know precisely what will happen.
Okay. Thank you, Lauren. I will continue with some of the pre-submitted questions here. And so they come from all kinds of corners of this challenge. And so one question regards to HAZIDs and HAZOPs, and if there are any references to the rate of severity of a given volume of an ammonia released to sea. And to those of you who may not be aware of that term, hazard identification is advising the design of ships. So I'm giving that question to you, Samie. Would you have anything to say on that?
I guess what I can add is that, yeah, like you mentioned, a hazard or a HAZOP, which is a hazard and operability study, are typically used to guide the design of the ship. And these are increasingly used as tools as part of the approval process for the design of ships. And yeah, it helps us to better understand the systems on board and what hazards are that the crew can be exposed to. In terms of actual references, I guess it depends what companies who are undertaking these hazards and HAZOPs are prepared to release publicly. But I am aware that there are hazards and HAZOPs that have been done between different industry groups that actually have released the results of these assessments publicly. So maybe following on from this session, we can provide references to these assessments that have been released in the public domain.
Thank you. And while I have you answering there, would you say anything about the different tank types that are required for onboard applications? We had a question regarding that.
Yeah, of course. Yeah, so that all depends on I guess the volume of ammonia required. And then the mode of storage, like I mentioned in my slides, whether it's refrigerated, semi-refrigerated, or pressurized. But what we've seen from the preliminary design so far is that we'd expect IMO type C or type A tanks. And in terms of the size, these can, in the designs we've looked at, they can range from anything from 2,000 meters cubed, 2,000 meter cubed to 4,000 meter cubed. So all depends on the type of storage and the volume required.
Thank you, Samie. Steve, or perhaps Lauren, would you be able to say anything about how the environmental impact of an ammonia release changes with the scale of the spill and how that compares to other marine fuels?
Yeah, sure. I mean, in the study we did look at obviously the receiving environments to understand what the potential environment impact of those releases were, and obviously if an event such as a catastrophic release, in essence, that's one method we can quantify that risk in relation to the environment. But I would say there's a lot of work we need to do in relation to quantifying those risks further, and also putting in place mitigation process to be able to reduce those risks in the environment.
Yeah. Thank you. I'm gonna change my screen here so that I can see the questions that are coming in the Q&A. First, an obvious question, if these presentations will be made available. Yes, they will. They will be made available on the AEA website later. There is a question here about nitrogen emissions coming from combustion of ammonia and how that compares with gas oil. The question is referring to NOx, but as we know, ammonia, when combusted, has a number of nitrogen emissions. Marie, would you like to say something on that?
Yeah, and maybe Samie or Steve will add more. But the simple answer is we don't know yet. I think we will have to test this in an engine once we have it, and see how we can, what like technical sort of measures we can put in place to manage those emissions. So we don't know, and I think it is really important to understand this better for both the air quality and climate aspect of ammonia.
Samie
or Steve, do you want to add to that?
Yeah, I can add to that. Yeah, Marie is spot on there. Until we know the data from how these engines run, then it's hard to answer that right now. But in terms of the designs that we've looked at, we are expecting that you would need some type of what you call like an SCR unit, so selective catalytic reduction, that would deal with these kind of unwanted emissions.
Possibly just to add to that, I mean, the Port of London obviously falls within the Transport to London kind of zone in relation to air emissions and air quality. So there's a lot of work that PLA are doing in relation to looking at how they can reduce their existing emissions and how that can be considered further, NOx in the future, because obviously they've got to meet the London air quality standards.
Yeah, and we are also increasingly aware of how ammonia also impacts the global nitrogen cycle. There have been some questions coming in on that as well. And this, I saw, Marie, you also answered directly in the Q&A here that the global nitrogen cycle has not been part of the scope in this assessment here. But is this something that perhaps will be included in another assessment later?
Well, I think it should be included in some assessment. Whether it will be EDF's assessment, I don't know. But I think, and I guess that was one of the lessons we learned from publishing this study, is that it does answer questions, but it also opens many, many more. And I think there's so much we don't know about, the safe use of ammonia as marine fuel. That's why a lot of work is still needed to understand it better.
Yeah. Samie, perhaps this question is for you. Are you aware of any development of any ammonia spill response plan similar to oil spill response plans. Is that something that is being looked at?
Oh yeah, that's a good question. I think that's something that does need to be looked at and probably would need to be developed. But I think what's key difference between ammonia and what's typically used as a fuel is how that ammonia would behave in a spill scenario. So whereas an oil spill would be quite persistent and would stay in there and would linger, ammonia dissipates very quickly. So it all depends on where that spill would take place. If it's in the open ocean in the middle of the sea, my feeling is that'd be very hard to try and contain any type of spill. But say if a spill was to take place in a confined space near a port or a harbour, that there are potential ways that you can contain that spill, whether that's through a neutralizing agent, or if there's a gas cloud, you can use some type of water spray to minimize the size of that gas cloud. But yeah, I think that's something that definitely needs to be developed.
Yeah, it's not like heavy fuel oil that kind of is possible to kind of just scoop up or just it really dissolves and it's already, yeah,
exactly.
Yeah. There is a question here if there has been any examples of any large ammonia spills at sea, and if you've been able to use any data from that and from any effects recorded on that. I don't think there is much, but maybe you have some further insight.
Not any that I've come across. I'm not sure if Steve and Ricardo came across it.
No, and again, you'd have to be in a position where you'd kind of almost have to have an environmental ecotoxicological team following around a potential disaster or incident where they could immediately start to undertake, the studies that would provide the evidence base. So again, we're fairly limited. I mean, very much within, many of you are aware of those kind of major oil incidents that have happened where a lot of environmental studies have happened on the back of it. And again, that comes down to Samie's points in relation to persistence in the environment. So, going back to my youth, Torrey Canyon, there's also the work that was undertaken, Milford Haven in the UK. So again, there's been lots of these evidence-based approach studies that have quantified, what the environmental consequences are of these, loss of containment events. However, ammonia is very much limited when it comes down to what's going on in the aquatic environment.
Yeah. Do you think, I don't know who is answering to this, but do you think that port states may require that a fuller environmental impact assessment of their economic zone maybe have to be assessed for them to accept ammonia as a fuel? Do you think that the kind of the environmental risk is going to be very specific to the geographic location, that this is similar to the bunkering studies being undertaken in Singapore with the GCMD? Will we see regional-based environmental assessment being requested? Do you think that's needed, or do you think that's something that they will ask for?
I can have an attempt at that. Maybe not so much on the environmental side, but as you do talk about ports and areas where you have like a local population nearby, the ports will definitely be interested in if you have storage of ammonia, and in the event of the leak, what are the consequences of that event? How far could that ammonia gas cloud spread? And what's the distance between local populations? That's just my answer from a population perspective.
Yeah.
And I suppose leading on from Samie, that's a lot of studies that our kind of terrestrial air quality team would be undertaking, for a whole, from a global level, for a national global level, down to various towns and cities around Europe and the world. So again, probably the the scientific kind of perspectives there. It's just applying it in this kind of scenario, I think.
What has been the reaction to this report from the wider environment? Are there any initiatives being kind of proposed already as a result from this report?
So I think the reactions were mostly positive in a way that, oh, this is research that we really needed. But also, as I said before, it really opened so many questions. And I am quite positive about it because I am aware of multiple projects looking at similar issues with ammonia, digging a bit deeper, or looking at different aspects. So I think that's great. Also, the IMO is working on the safety guidelines for ammonia, which I think should be finished next year. So we use the study to feed into the discussion as well. And we are hoping that many more reports will pop up soon to make sure that IMO makes an informed decision.
Yeah, thank you, Marie. I'm trying to find here a question for Lauren, who we brought in especially on the toxicity challenges here. Maybe, Lauren, you feel that there's a question I haven't asked. Is there anything you would like to bring forward?
I think there was a question in the chat. I think it reads, other than acute effects on fish, e.g. on gills, are there any data on chronic/reproductive effects in case of presence of elevated levels of ammonia? So thinking fish, the study that immediately leaps into my mind is Milner Alb. It's a little older now. It was year 2000, I think, who looked at sort of elevated concentrations of ammonia and their effects on fish, and they found that I think it was an acute study, so possibly doesn't answer the sort of chronic level so much maybe, but in terms of reproduction, they found that they sort of looked at it in two ways. First, it sort of looked at reproduction in terms of sort of fish egg survival, and because ammonia in sediment swiftly becomes sort of anoxic due to nitrification, that was one mechanism that it sort of affected fish reproduction. And the other sort of mechanism it found was sort of, if those fish eggs do manage to survive, then it very strongly impacts their growth, their organ weights, gill condition, and also the hematocrit. So just to sort of answer that question, yes, there is some research out there on fish reproduction, and ammonia is not considered to be a good thing surrounding it.
Thank you, Lauren.
Probably just adding to that, there's a little bit of evidence in relation to similar sort of thing with shellfish as well.
Yeah. So this is a good bridge into a rather tough question here. I mean, we are all here also because we are engaging in the sustainable energy shift of maritime transport. And so in order to reach that level in 2050, we don't have much time, and we need to develop infrastructure and fuels and engines at great speed. And so there is a question here that says, given that we don't have 100 years to learn how to use ammonia safely as we did with oil, and given the pressure we have to reduce emissions quickly, how would you balance the need to begin building out that infrastructure and ships and engines with the need to study ammonia impacts? Or how long should environmental studies be conducted before we feel confident to move forward with ammonia as a fuel? I mean, this is hopeless, pest and cholera conversation, really. But are you able to share your views on that?
I guess sorry. I guess, yeah, one point I could make is that ammonia is not a complete unknown. We have been producing it and transporting it as a cargo for many years now. So that we can draw from our experience there. Yeah, in terms of trying to speed up that process, again, it's a tough one, because for these ships to go through the correct and appropriate approval process, we have to consider all the different and new risks that ammonia brings as a fuel. So you're right, yeah, it's hard to balance the urgency required with the actual appropriate steps needed to ensure that all risks are adequately managed.
And I guess from the environmental perspective, yes, we've learned over 100 years, but we're probably thinking the last 2 decades where the technology and computer power that we have now is going on an exponential rate. So I wouldn't consider, we need 100 years of research before we understand. I mean, you look at what goes on with the computer e-learning in relation to some of these pharmaceutical trials. I mean, that's where I think I mentioned, those kind of ecotox studies could be used or adapted and put into some form of machine learning perspective and help us aid coming up with some of these some of the evidence base that we need to make our assessments.
Yeah, thank you, Steve.
I would just add that I think it's a tricky, very fine balancing sort of point to protect the climate while protecting ecosystems and human health. And this is probably the most difficult question to ask, to be honest. I think that it is important to get the engine and see what it does in real world. And also, as I mentioned during my presentation, I think there is a lot the shipping industry can do to reduce their emission now, and that doesn't have to be moving away from diesel now. I mean, yes, eventually, of course, but we know that the sector's emissions can be reduced significantly by quite small changes, and I think that that's where the focus should be now, at least in the meanwhile, because it's not just about when we reach zero, it is about the shape of the curve. So, it's about the cumulative emissions during the next 25 years, right? So that is important. And while we are waiting for some more data, some more studies, the engine itself to get some real world measurements, this should be the focus for the industry.
Thank you, Marie. We have 2 minutes left, and I'm going to give all of you 30 seconds to answer to the following question. To progress the sustainable use of ammonia as a maritime fuel, what is the most important thing that needs to happen next? Samie, would you like to start?
Yeah, I think the most important step is collaboration. This requires efforts from our ship designers and ship builders, the local the port authorities, local ports, the environmental agencies. We have to look at this holistically, and everyone has to have an input and work together. So the risks of ammonia and whichever other fuels are considered in their totality. So I think, yes, just to reiterate, collaboration is the key.
Excellent.
For this to be successful.
Thank you. Steve?
Yeah, I mean, I totally agree with Samie. I mean, also I'd add, I suppose it's putting it also, we're talking about, uncontrolled releases of ammonia, but it's, I suppose, bringing on board more safety measures and how we can implement those in relation to reduce the potential impacts of spills, and also, support that going forward with, I wouldn't say further toxicological studies, but perhaps look at certain species groups that may be more vulnerable and susceptible to ammonia in the environment.
Thank you. My clock just stroked the hour here. So Lauren and Marie, I'm sorry, but the time is up. I need to thank my great panelists here, and to all of you, over 90 of you who have been listening here today. Please reach out to us if you have any further questions and would like to follow up on anything that was said today. The recording will be made available, a summary will be written, and the presentations will be made available on the website. Thank you, all of you, for participating today. Samie, Marie, Lauren, and Steve, thank you so much.
Right. Thank you, Sofia.
Thank you.
Thank you so much.